Hello friends, I welcome all of you. Today we are going to start electrochemistry. This chapter has a great importance for in our day-to-day life as well as in the industries and in the nature also. What is electrochemistry? We will define later on it. Before that, where we can observe the use of electrochemistry. Now we can start it with ourselves. In human body, respiration, digestion, impulsion of nerve signals, all these biological reactions based on electrochemistry concept. In the nature, photosynthesis, corrosion depends on electrochemistry. In industries, various types of processes, mainly the cell which we use in our day-to-day life, either in the mobile phone or any other smartphone or in the form of battery, based on electrochemistry. So electrochemistry is a wide application in our day-to-day life. And other than these, the electrochemistry is going to be help to reduce pollution. And scientists are trying to develop such type of devices which may be in the form of cell can reduce the pollution. So electrochemistry has a wide application for us. So we have to discuss about this electrochemistry. In this part of electrochemistry, we will discuss what is electrochemistry, what is the meaning of redox reactions, what is the meaning of cell, what is electrochemical cell, electrolytic cell, conductance, conductivity, molar conductivity, equivalent conductivity, Nernst equation, corrosion, and the application of electrolysis and primary and secondary batteries. So this is the brief outline about this electrochemistry. So today we will discuss about electrochemistry. Electrochemistry. The definition of electrochemistry. The definition of electrochemistry. The electrochemistry may be defined as the branch of science which deals with production of energy either in the form of chemical or electrical in a spontaneous reaction, and that energy used to bring about non-spontaneous reactions. This is the definition of electrochemistry. The branch of science which deals with the production of energy in a spontaneous reaction, and that energy used to bring about non-spontaneous reaction. This is electrochemistry. Now the basic reaction which related to electrochemistry is redox reaction. Electrochemistry based on redox reactions. And the meaning of redox reactions you know very well, where oxidation and reduction proceed simultaneously. Means where the oxidation reduction proceed simultaneously, that reaction is known as redox. The best example to explain the redox reaction, that is reaction between copper ion with zinc metal. It converts into zinc ion plus copper metal. Copper ion present in aqueous state, zinc in solid state, zinc ion aqueous, and copper that is in solid. So this is the best example to understand the redox reaction. Okay. Oxidation reduction have various concepts to define themselves. We can start oxidation reduction on the basis of oxygen. Gain of oxygen is known as oxidation. Loss of oxygen is known as reduction. Second criteria, that is hydrogen. Loss of hydrogen, that is oxidation. Gain of hydrogen, that is known as reduction. The third criteria, that is metal or electropositive element. The loss of metal or electropositive element, that is known as oxidation. The gain of metal or electropositive element, that is known as reduction. In the terms of non-metal or electronegative element, the gain of non-metal or electronegative element, that is known as oxidation, and vice versa for reduction. Means loss of non-metal and electronegative element, that is reduction. Next, that is electron. Gain of electron, that is known as reduction. Loss of electron, that is known as oxidation. And one step ahead, in the terms of oxidation number, when the oxidation number increases, that is oxidation, and when the oxidation number decreases, that is reduction. So we have various concepts to explain oxidation and reduction, but the condition is that neither oxidation nor reduction proceed individually. Where the oxidation, reduction will be there, and combinedly both will convert into redox. So this is the example of a redox reaction. We can clearly observe that in this reaction, copper is going to convert into Cu2 Cu ion, and zinc is going to convert into Zn2 plus ion. So here, the best technique to explain the redox reaction, oxidation or reduction in the terms, that is electrons and oxidation number. Oxidation number should be preferred over electron also. Okay, look at here. If you observe this example, Cu2 plus converted into Cu, a positive ion converted into a neutral atom. It means this process only can happen with the gain of electron. So, gain of electron is known as reduction. So, this is the part of reduction in this reaction. In the second part, zinc converted into Zn2 plus, a neutral atom converted into positive ion, that is loss of electron, that is known as oxidation. So in this way, we can understand the concept of redox and the concept of oxidation and reduction. In this reaction, some terms are very important which generally used when we are dealing with the electrochemistry. That the first term is oxidizing. oxidizing or oxidant. The meaning of oxidizing or oxidant is the species which is going for reduction. It means itself it reduced. Means that species is going for the reduction and reduced, that is oxidizing or oxidant. In the terms of electron, the species which gains electron, that is known as oxidizing. Gain electron. So in this equation, you understand that Cu2 plus is going to gain electron and reduced into Cu. So here oxidizing will be Cu2 plus I. In the same way, reducing or reductant. Reducing or reductant means that species which is going for oxidation. If the species is going for oxidation, it means itself it is oxidized. So we can say it oxidized. And in terms of electron, it lost electron. So in this equation, zinc losing electron, going for oxidation and oxidizing into Z plus. So here the reducing is zinc atom. So this is the basic of electrochemistry. Redox, example, oxidizing, oxidant, reducing, reductant, reduced and oxidized. After that, discussion about definition of electrochemistry. The next part which we have to deal, that with is conductance. Conductance. And you know very well, the conductance belongs to conductor specially. Otherwise, on the basis of conductance, we can classify solid into three categories: conductor, semiconductor and insulator. But here we are dealing with conductors. So normally the conductance belongs to conductors. What is the meaning of conductance? Conductance means to flow current with easy through a conductor. Means a conductor, how much is easier manner can flow current, that is known as conductance. Conductance is the reciprocal of resistance. Reciprocal of resistance, that is R. And resistance obstacle in flow of current. Obstacle in flow of current, that is known as resistance. And resistance is directly proportional to length of the conductor and inversely proportional to its cross-sectional area A. So combinedly, we can say resistance is directly proportional to L upon A. And when we remove the proportional symbol, there is a new constant that is known as rho. So the formula of resistance will be here, rho into L upon A. And again, what is rho here? Rho is known as specific resistance when the length of conductor is 1 centimeter and cross section area is 1 centimeter square. In that situation, when the length of the conductor is 1 centimeter and the cross section area is 1 centimeter square, that is known as rho, specific resistance. And the other name of specific resistance is known as resistivity. Resistivity. So this is the concept of resistance, specific resistance, resistivity. If we rearrange this equation, rho is equals to will be here R into A upon L. Rho is equals to resistance into cross sectional area upon L. Now we are dealing with here what is conductance? Reciprocal of resistance. And the symbol of conductance, that is capital G or capital C also. But capital C generally used for concentration and coulombs. So it is better to use capital G here. So the capital G is equals to will be here 1 upon R, reciprocal of resistance. This is the mathematical formula for conductance. And we know very well the unit of resistance is ohm. So it will be 1 upon ohm, or we can write here ohm inverse or mho, or we can write in this manner also, is the sign of ohm inverse. So this is the general introduction about conductance. Conductance belongs to conductor. To flow current, what is the meaning of conductance? To flow current with easy through a conductor. It is reciprocal of resistance. What is resistance? Obstacle in flow of current. And resistance is directly proportional to length of the conductor, inversely proportional to cross-sectional area. So resistance is equals to L upon A. So R is equals to rho L upon A. Rho is a specific resistance, which is known as resistivity. How can we define specific resistance? When the length of conductor is 1 centimeter and cross-section area is 1 centimeter square. In that situation, the resistance of a conductor is known as specific resistance. So the formula of specific resistance is equals to resistance into cross-section area upon L. So the mathematical formula of conductance, that is G is equals to 1 upon R. G is the symbol of conductance. Unit of the conductance will be here 1 upon ohm. It is equals to ohm inverse, and this is the sign of ohm inverse. So this is about conductance.